Hello, my name is Ms. Vercellus, and I'm going to teach you the part 2 of graphing logarithmic functions when the logs are transformed. So here's transformation form of a log. We could have a number multiplied in front of the log. That would be a vertical stretch or shrink. Negative being the reflection over the x-axis. Log base b, if this is greater than 1, remember our log function will be growing, shaped like this. Between 0 and 1, our growth function will be decreasing, shaped like this for the log that's decreasing. And then plus or minus h, inside with the x is our shift left and right. Outside those parentheses, not part of the argument, outside is our shift up and down. So here's how I would graph transform log functions. Example 1, graph f of x equals log base 3 of x minus 2 plus 1. My first step would be to create the parent function table. Remember, this is the inverse of an exponential. I'm using -1, 0, and 1 for my y values. I'm looking at the base, 3. 3 raised to the -1 is 1/3. 3 raised to the power of 0, 1. And 3 raised to the power of 1, 3. Now that I have my parent function table, I'm going to shift my graph to the right 2 by adding 2 to all my x values. Add 2. 2 and 1/3. Add 2. 3. Add 2. 5. Lastly, I'm going to shift my table up 1. So that parent function table, all the y values, I'm adding 1 so I can shift up 1. So 0, 1, and 2. Here's my transform table. I'm going to plot my points. So that's 2 1/3, comma 0, 3, comma 1, and 5, comma 2. Now I know the shape, because this is a growth base, is going to be increasing, and I also know my asymptote shifted to the right too. It's no longer x equals 0. Vertical asymptote shift left and right with the function. There's my graph. Let's try another example. Example 2. Graph f of x equals 2 times the natural log of x minus 1. I'm going to make my table again, my parent function. So x and y. This is a log function, the inverse of an exponential. So -1, 0, and 1 are my y values. Natural log has a base of e, which is approximately 2.718. So e to the first power, 2.718. E to the power of 0, 1. And e to the negative first power, could use a calculator for this, would be 0.368. Now I'm going to take these values and I'm going to apply the two transformations. So this is a stretch, vertical stretch by 2. Vertical stretch. So I'm going to multiply all my y values by 2 times 2. -2, still 0, and 2. Then I'm going to shift all those y values that stretched down 1. Down 1. So now I'm at -3, down 1, -1, and down 1, 1. There's my transformed points. Plot them approximately. You can see base E is still growing. My asymptote did not shift left or right at all, so it's still at x equals 0, and I can sketch in my log curve. Now, what if I gave you a transformed function and just asked for the key features? Here's what I would do. Example 3, given g of x equals log base 3 of x minus 6. Identify the asymptote, domain, and end behavior. I know Log base 3 is a growing function. It's increasing. And this one shifted to the right 6. So I'm going to draw a sketch for myself. I know that asymptote shifted to the right 6 and it's growing. So my asymptote is at x equals 6. My domain is 6 to infinity. And my end behavior, the right side approaches infinity. As x goes to infinity, the function's going up. And on the left side, we're approaching the asymptote. So as x approaches 6, this side, the function is approaching negative infinity. Let's try one with a base between 0 and 1. Last example. Given f of x equals log base a half x plus 5 minus 1. The asymptote is at negative 5. It's shifted to the left. So the domain is negative 5 to infinity. To get the end behavior, I'm going to sketch a decreasing log. So here we go. As x goes to infinity, the function's going down. And as x approaches negative 5, the function's going up. If you have any questions on graphing logs, send me an email, go to the Lit Center, or Google it. You can do this. Have a good day.